shaded region. The area of the shaded region is going to be the area of the rectangle minus the area of the semicircle. I had the area of the rectangle minus the area of the semicircle. So if we put this idea together, then we're going to get the shaded region. We were trying to create the idea. We created the idea yesterday and used the rubbing out technique to show us or to prove that it was so. Because we were saying that if we find the area of the rectangle, like no, all right, say I find the area of the rectangle, right, then it's going to be everything in this region. We spoke about that. So just let me just rush it back for people who were not, you know, here. So we're saying it would have been all of this area, all of that, all right, all of that. Everything inside this rectangle would be shaded, which is not necessarily what the question is about, because the question never shaded all of the rectangle. It only shaded a certain part of the rectangle, all right? And those who are really looking would see that up here of the rectangle in a shade. But we're saying that when we find the area of the rectangle, it's going to give us every part of the rectangle. So what we're going to have to do now, let me see if I can flip it. Can I flip it? Oh, I can rotate. What we're going to do now is just rotate this. Yeah. And then we're going to pull it down to show you. Yeah. All right. Everybody see what I'm going? Look for yourself. When you find the area of the rectangle, you already find the area of the semicircle too, because the semicircle is in the rectangle. So it's like we are rubbing out the semicircle, the area of the semicircle. Let's imagine that you're rubbing it out. Look there. When you rub out the area of the semicircle, you realize that you're left with the shaded region. So let's put together some mathematics now. Okay, go and put together, make a duplicate of this quickly. Put it down right here. So the area of the shaded region is going to continue working with that, right? So we're talking about then, in terms of numbers, we're talking about 10, my bad, times 7, and we're getting 70. Right, so we're getting our 70. And, well, we're just going to say units. All right, so it's square units, because they never gave a measurement on that. So we're just going to say square units. Everybody, let's duplicate this part. This, which is the area of this circle. But guess what? We're going to have to understand that it's a semicircle we're finding in the end. You know? So the area of this circle is pi r squared. Pi times r. Now, this is the issue. What is the radius? By 2 will equal to 3.5 for the radius. Right? So we're saying that this is something that we definitely would need to have while we're about to work out the problem. Because some people might be saying, oh, you get, because we're saying the diameter is 7, therefore 7 divided by 2 will give us the radius. All right? So now we can use that radius, which is 3.5, in the formula to solve the problem. Let's put that on our calculator to see what we get. What do we want to put on the calculator? The pi r squared, 3.14 times 3.5 times 3.5, 8.47. Right? Square units. That is the area of the circle. What is that area of the circle we want? We want the area of the semicircle. So we're gonna have to put on something here. So we are saying therefore area of semicircle is going to be half of it. So we're going to divide it by 2. 38.47 divided by 2, and we'll get our answer for that part. All right, so the final thing is 19.24 square units. Here we are. That's it. So this is now the semicircle. So we're gonna put it together now. Now feel now where you have to do some workout. This is how the things are. We found that the area of the rectangle long ago, it's 17. Then we found the area of the semicircle, which is 19. So we're talking about 70 minus 19.24. Tell me if everybody agree with that working out. 50.76.